go over some questions and tell you if they're relevant to your test or not, because not many limit questions are. Like I said, the limit questions I'm going to ask you are more of the graphic and algebraic, but there are some that's a little bit off the wall. So that's probably the ones that you are sending me. So we'll start from the first. This is 1.1, 31/11. Number 31 in the book, number 11 online homework on 1.1. First of all, is it a test question? I don't have any idea because I haven't looked at it. It could be. It could be a test question because this is a graphic representation. I'm going to blow it up a little bit. Okay, now it's asking, this question is asking, I'm going to put my handy dandy, where is my, hold on a second. Can everybody see my screen okay? Since y'all weren't talking to me.
Yeah, we can see.
Y'all don't start talking and interacting with me. You know what I'm going to start doing in my classes? I'm going to start doing group work. And we're going to start breaking up into little rooms. You know, I can do that now. How would y'all like to do group work?
That sounds fun.
You're kidding. There's Miss Holcomb. There you go. Usually 90% of the people hate group work. I'm going to start making y'all do group work if y'all don't start interacting. All right, this thing says limit of the function, and they don't give you an algebraic function. They just tell you this means right here, look at the graph. That's what that means. Okay, and tell me what's happening as x approaches -5 from the what? I'm going to put the negative right here in red. What does that mean? That means
from the left.
From the left. So as x approaches -5 from the left. Now, left is an important word, and I'm going to highlight it in pink to go with the red marker, the negative. So that means that this right here, I wish I could, let's see, can I do this? Shoot, I can't. Okay, I can do this. I'm thinking out loud, people. Hold on. Let's see, pull this up. Okay, are you coming up or not? There we go. And pull the homework back up. Give me a second, y'all. And do I have... I don't think I do. I was hoping I had... Well, I can use this. Okay, so where is -5? -5 is right there. Well, Hubert, what are you doing? I'm taking this red box and I'm covering up the right side. Now, why am I doing that? Why am I covering up the right side of -5? Because you're not supposed to be looking at the right side, Hubert. That's right, class. You're supposed to be looking at the what? Left side, Hubert. Thank you, Miss Hollister. You're supposed to be looking at the left. So now look at the left. As I approach -5 from the left, I'll even put a little arrow right there. Oh, well. As I approach -5 from the left, what is my y approaching? That means I want y'all to interact with me. Okay, nobody's going to interact.
Is it 0?
What's this y right here, y'all? Look at the function. There's this function.
Oh, I'm sorry. I can't see that. It's kind of small.
Oh my God. Hold on. Let me blow it up to. Now I got to move everything thanks to you, Miss Hollister. Now I can't move it. I'm not used to this whiteboard application, so just hold on a second. I can't get onto that. Well, I don't know why I can't move it, but I can't move it right now.
Is it 6?
It looks like, let's see, 987. 987, yeah, 7. So the answer should be 7. That is a test question. The reason it's a test question, I'm just going to do this like this. There. The reason it's a test question is because I told you that I would ask you questions like this. Okay, there it is. Why am I covering up the right side of -5? Because you're only supposed to be looking at what? The left side. You know, y'all can talk. Y'all can leave your microphones open as long as you don't have a lot of, background noise. You can leave your mics open. It would, that would help with the interaction. So if I cover up the right side, the only thing left is the left side. So as I approach x is equal to -5, there's -5 right there. I'm coming from the left. Then what is my function approaching? It's approaching 7. And that's how you read a graph. That's how you read a limit. That's why this is a test question.
Okay, Hubert, I sent this question, and like the difficulty I had on the homework, what I didn't understand is where you start counting from. But you just explained it. So you start at the end of the graph.
You start over here from the left.
All the way at the left.
Yeah, negative infinity right here. Just keep going, keep going.
That's what I was confused about.
Yeah, as you go this way, as you get right here, here you are y. And then when you get here, you're right about there. And then when you get here, you're right there. And then when you get here, you're right there. And then when you get here, you're right there. And when you get to -5, you are at or converging on y is equal to 7. It's kind of like reading from left to right. You're used to reading from left to right. This one says you're coming from the left-hand side. And that is a good test question. Now, the reason I like this question is because it's short and sweet. I don't like 15 questions about one question. I can't stand those questions. All right, so this is short and sweet. Good test question. Let me delete that one. And let's see if I can get rid of this. There we go. This is 1.135/12. 35 in the book, number 12 online is like both of those. First of all, is it a test question? Let's see, it says same thing, same type question. So I'm going to take my handy dandy do-jigger maker, and I'm going to cover up everything to the right of -2. So which way do we read? Crap. Hold on. Which way do we read, people?
Left to right.
Left to right.
Read from left to right. So as I hit -8, I'm down here. As I hit -6, I'm right here. As I hit -4, I'm right about here. And when I hit -2, I'm at what? I think that's -1. 2, 3, 4, 5, 6, 7, 8. I'm at -1. So now, since it is an open circle, it is discontinuous, but I don't know. They may say it does not exist since it has an open circle. No, I didn't think it did. It's discontinuous. So that would be -1. There are some books that would say it's not, it's discontinuous, therefore it doesn't equal. So that's a good test question. I don't mind that one. Now, you know what these homework questions are telling me? Telling me that some of y'all aren't used to limits. That's why I tell y'all to send me questions so I can, you know, determine how many of y'all have seen limits before. 1.138 is also called interaction, which y'all suck at. 1.138/13. All right, use the graph. Okay, now does this one approach either side? No, this one is approaching from both sides. As x approaches 3, so we're going to come from the left and we're going to come from the right. So here I go. I'm going to take my handy dandy cursor. I can't do anything else. What's happening when I approach 3? I'm going to draw a line at 3. Okay, so I'm going to take my handy dandy, hold on a second, translucent and a line, and I'm going to make it yellow at 3.
Hubert, I have a question really quick.
All right.
So when you're doing the limits and there's 2 points on one line, how do you know which one to use for your answer?
Okay, that's what I'm fixing to get to right now.
Okay.
All right. This one right here is saying, since there's no negative and positive on the right-hand side, that means we're approaching 3 from the left and the right. Okay, here I go. I'm going to take my handy-dandy cursor, and I'm going to approach 3 from the left. So at -8, I'm right here. At -5, I'm right here. At -4, I'm right here. At -2, I'm right here. At 0, I'm right here. So at 2, I'm right here. And at 3, what y am I approaching?
6.
6. So I want to go over to my handy dandy whiteboard. And I want to write down what I'm thinking on this problem. Here's 3, and I'm approaching from the left side. I'm approaching 6. All right, now we're going to approach 3 from the right side. So I'm going to take my cursor, and at -8, I'm way the heck up here. At -6, I'm right about there. At -5, I'm right there at 0. I'm sorry, not negative, at 5. At 4, I'm down here at -2. And as I approach 3, I'm getting close to what? I'm pointing at it.
-2.
-2. So down here, I'm getting close to -2. Does -2 equal 6? Yes
Nope.
or no?
No.
They're not equal. Therefore, if they're not equal, does not exist. And I think we talked about that last time we met. So this limit does not exist because -2 does not equal +6. The two limits has to equal. That is a test question. Okay, now I'm going to stop right now and see who's got a question, because this is limits. And I know that some of y'all, that's why I'm trying to do the cursor on the left, and then from the right. You got to go from the left and the right because this 3 doesn't have any signs after it. So you're approaching 3 from the left, and you're approaching 3 from the right. And that 3 right there, x approaching 3, right where that cursor is. What is your y? Well, if you come from the left, your y is 6, or approaching 6. As you come from the right, y is approaching -2. -2 will never equal +6, so this limit does not exist. Hopefully there'll be another one like that because I like that one. All right, here's another one. 1.151/17. Okay, we're approaching 3 from both sides. So I'm going to put a handy dandy line at 3. Actually, this is an easy question. Why did they put all the stuff all over the graph? Anybody want to take a shot at that? Why they put everything over the graph, but really it's an easy question. They're trying
to confuse us.
They're trying to confuse you. So tell me what happens when you approach from the left. When you're approaching 3 from the left, okay? So I'll draw dots. At -2, we get maybe what? Close to -3 right there. And at +1, we get close to -1. And at 2, we get almost 0. What do we get? What are we getting toward when we approach 3 from the left? From the left. Well, it's way up here. Looks like infinity to me. See, here's 3. As I get closer and closer to x is equal to 3, where is my red line going?
Infinity.
Going to infinity. Does it ever cross? No, it converges. So it's going to infinity. So this question, and I'm doing this, I'm trying to do both. I'm trying to show you what's going on with the whiteboard. This is 3 right here. X is equal to 3. And I've got a line going something like this, like that. And I got a line going something like this, like that. All right. As I approach 3 from the left, here's my y. It's going up, it's going up, it's going up, and it keeps on going, but it never what? This is the limit theory. If you take half of the first step, do you ever reach the wall? No. Does this line ever cross this dash line? No. But it keeps approaching. It keeps going to what? Y is equal to what? Infinity. It keeps going because it doesn't ever cross. So as x approaches 3 from the left, we've got infinity. Okay, now what happens when I come from the right? Well, at this point right here, I have this point. At this point right here, I have this point. At this point right here, I have this point. At this point, that's the x-intercept. And then at 3, I'm close to what? Whatever that number is, y right here, because I hit right in there. So that's not going to equal infinity, so it's not going to exist. But let's look. What is that? -1 at 3? So the limit does not exist because positive infinity does not equal -1. Uh-oh. Then I must be wrong. It must be -1 then. I don't think that's right. -1? No. Hold on a minute. Oh, okay. I messed up. I didn't think about the bottom. Okay, let me show you what I forgot to show you. All right. X goes to a certain point, and then it comes up here and hits this point. And it goes, so as I approach, it's coming right here, so it does exist. Let me show you what I'm talking about. Let's do, trying to think of a problem we could do right quick. Hold on a second. Let me get the calculator. No, the calculator. And let's see if we can do x cubed. Y is equal to, turn it on. Y is equal to x cubed plus 2x squared. I hate these calculators. Hold on. X cubed plus 2x squared plus 3x I'm about ready to quit. Plus 3x plus 6 parentheses divided by x minus 2, or yeah, x minus 2. X minus 2 in parentheses. And I bet you it's not going to come out like I want it to. X minus 2. Graph. Turn off stat plot. Zoom. Standard, or zoom standard is 6. Nope, that's not going to do it. All right, I can't show you what I want to show you right now, but when a function is infinite, right here on 2, okay, it's a little bit off. It comes back, it goes up here, and then it comes back down here and goes up through here like this. And that's why am I approaching -3, or if I'm approaching 3 from the left, it goes up here and then it starts down here and comes up. So I am approaching -1 when I approach 3 from the left and I approach 3 from the right. So the answer here would be -1. And I made a mistake on that one when I was explaining it to you, because I thought it was converging on -3, and it's not. It's converging on 2. See here, let me draw another line. And I don't mean to, I'm not trying to confuse you by no means. I'm just trying to, at 2, it never reaches 2. And then after it passes 2, it starts again. Of course, I can't draw that right, so I'm going to move it. There. Okay, so the function goes to 2. It never reaches 2, and then it goes to 10.1, 2.999, or 1.999 to 11, 1.99999 to 13, 1.99999 to 15. And then it starts at 2.01. At 2.01, it's negative 15. At 2.02, it's at negative 13. At 2.01, it's at negative 10, and so on. And that's why I thought it was going to 3, and it's not. It's going to 2. So that's where I made my mistake. Okay, so the answer is negative 1, because both of them approach right here at 3. Sorry about that. Let me do another one just to make sure you understand. Let me hit similar question. All right, here's another one. Okay, I'm going to put the green line if it'll let me, which I don't think it will. Let's see if it'll let me after I... Why don't it let me move the dadgum things after I draw it? Sucks. German dadgum Russians. All right, let me erase them and I'll start over. All right, so I'm going to put a green line at, that's what I should have done on the previous question. I'm going to put a green line at the limit, which is 1. Okay, there's the 1. In other words, it's approaching 1, but it never touches it, jumps over 1. And we are probably going at 3. All right, so as I approach 3, here's 3 right here. I'll color it yellow. I don't know why I just did half a line. Okay, there's 3. As I approach 3 from the left, okay, 3 here, negative 6 is up here, negative 4 is way up here. It's approaching 4, and it doesn't touch 4. Then it jumps over, and then it comes to 2. At 2, you got a little bit negative, and then at 1, negative 1, you got positive, and then it approaches 1, jumps over 1, and we're still approaching 3. As I approach 3 from the left, I'm approaching 1. As I approach 3 from the right, 10, boop, 8, boop, 6, boop, 5, boop, 4, boop. As I approach 3, I get closer to 1. So your answer is 1. Okay, so when you're doing these problems, you've got to, you've got a, let's see if I can copy this. No, it's not going to let me. It ain't going to let me copy anything. I got to figure out how to do that on this app. This is a new application, if you're wondering. Okay, you got a vertical asymptote at negative 4 and a vertical asymptote at positive 1. You need to draw those in there so you can jump over them. So as x approaches negative 4, it jumps over negative 4. It goes from negative 4.0001 to negative 3.99999. And when it gets to negative 3.99, it jumps down to here. Negative 3, it's about right there. Negative 2, it's about right there. Positive 1, negative 1, it's about right there. Jumps over 2, or jumps over x is equal to 1. Boom, over here. And as I approach 3, my 1 is right there. Okay, as I approach 3, my cursor is right there, and it's approaching 1. And then as I approach 10, approach from the right, that 10 is right there, that 8 is right there, that 6 is right there, that 4 is right there, and that 3 is approaching 1. So I'm approaching 1 from the, as I approach x from x equals 3 from the right, I'm still approaching that 1. So that's why the answer is 1. I hope that helps. Can somebody, whoever sent this question, I hope it helps.
Yeah, it helped.
Okay, next. And this is why I get y'all to send in the homework, because if you don't send in the homework, I don't know if you know it or not. Some people are going, oh, I see what he's doing now. Duh. 1.165/21. Oh. All right, this one says graph the following functions, then find the specific limits. All right, well, first you type this in your calculator. You're going to have a vertical asymptote at what? -3. So where do we have a vertical asymptote at -3? Alpha or delta? It's one of those two. All right, remember that the 1/x function looks like this. This is the inverse. So I think it's alpha. And I didn't even plot a point. I didn't even use a calculator. Should you be able to do that? Yes, because you know your parent graphs and you know the vertical and horizontal shifts. Okay? Now, what does it say right here? Limit as x approaches -1. So I'm going to blow this up because we need to blow it up. All right. We know that there's a vertical asymptote at 3. So I'm going to put a green line at -3. 1, 2, 3. So it's this line right here. That should be -3. All right, there's your vertical asymptote. So when you approach an x, you got to jump over that green line and keep going. All right, so, and we are approaching -1. So I'm going to put a short yellow line at -1. Right here. Now, I'm going to take my dot that I use. I don't know how I use it, but there we go. Okay. At -10, I got a -1. At -5, I think that's 5. 1, 2, 3, 4, 5. I got a -2.5. At what is that, 4? I got like a -6. And then I jump over -3, and I'm approaching 1. Well, it jumps up here and comes down. Well, what's at -1? Well, -1 is 1, 2, I don't know. What is that? Looks like 3. But I'm going to put a dot right there because that's where, somewhere in there is that negative what? -1. So g of x equal to -1, I'm coming up on, looks like 1, 2, 3, somewhere around 2 to 3, somewhere in there. Now, where's -3? Well, -3 is right here. Well, we have infinity at -3 because -3, you're approaching infinity on both ends. That's that green line. So -3 is infinity. And I don't know, I can't really tell. It looks like -1. It looks like, I think they want it to be 1, 2, 3. I think they want it to be 3, but it's not exactly on 3. So let's see what they ask. Let me hit my handy dandy cursor and let's go down. Okay, -1, I'm going to put 3. And it may be wrong because they may want something more detailed. Yeah, they're going to want, I don't know how you could tell that. 1, 2, 3.3, 3.1. I'm just going to answer 3.1, 3.2. And what's 7 divided by 2? 3 1/2. Okay, I'm sorry. I don't know how you would ever get that without blowing that graph up longer. I don't know how you would ever get that. And this would be infinity. So I'm going to put infinity. It actually, It's negative infinity to positive infinity, but I don't know if they want that or not. So let's type in negative infinity. They say no, does not exist because negative infinity does not equal positive infinity. That's it. All right, who sent that question? Does that help? I would not put that on a test question because I don't think that's fair, you being able to get 3/2 from that graph. Who asked that question? Somebody have a question?
No, I was gonna say I got 3.5. I plugged in -1 to the equation and got 3.5.
Well, I wasn't even thinking. I was thinking on the graph. I'm sorry. Thank you. Mr. Cox is correct. I wasn't even thinking about that. Take the -1 and plug it in the graph. Plug it in the function. I was thinking strictly graphing. I'm sorry. Yes. Plug in -1 and then you would get 7/2. Thank you, Mr. Cox, for breaking up my mind on that one. I was thinking graph. -3, you get positive infinity, negative infinity to positive infinity, and negative infinity and positive infinity do not equal, so therefore it does not exist at -3. So since Mr. Cox helped me out there and reminded me to plug into the function, that is a good test question. Next. 1.167/22. I feel like I'm doing y'all's homework for you. Okay, 1/x. That +2 is a vertical shift. So which one has a vertical shift of +2? This one, and this one is the inverse, so that's not it. It's this one. And what's happening as x approaches infinity? Where's infinity? Okay, as x approaches infinity, there's positive infinity right there. So it looks like it's approaching. Let's blow it up. As I go out here, because this is infinity right here, let's put a little, this arrowhead right here is called infinity. All right. So as x keeps growing and growing and growing, I'm actually getting close to what? 2. Because it keeps converging on to 2. So that would be your answer there. And what about as x approaches 0? As x approaches 0, I got negative infinity and what? Positive infinity. So therefore, it does not exist at x is equal to 0. So your answer will be 2 and 0. Or, sorry, 2 and does not exist. And I'm trying to get there. 2 and does not exist. Good test question, another good one. That's just like the one we just did. You got to know your parent graphs. If you don't know your parent graphs, then you got to rely on a calculator, and that's not a good thing. All right. Ms. Chakowski, you don't talk much in class. Did that help? She may not be. Yeah, there she is. Okay. She's not going to talk to me. She probably went back to sleep. All right. So we'll delete that one. 1.183/25. I don't like piecewise functions because they confuse a lot of students. So I'm going to explain it to you, but I do not usually put piecewise functions on a test. All right. Select blah, blah, blah. What is happening to the function at x is approaching 2 from the left? So I take my handy dandy, I'm going to make it translucent so that way we can see through it, I hope. Approaches 2 from the left. Oh, gosh. Hold on a minute. Box. Thank you. 2, so I'm going to cover up. Okay, so somebody tell me, what is y approaching as x approaches 2 from the left?
Can you go to the screen?
Y'all can't see my screen?
We can see you and then the problem's minimized.
Problem is minimized.
It's
Or at least
1.12. It looks fine to me.
Never mind, I
Okay.
just fixed it.
Okay, Miss Hollister's on drugs, y'all. Should we have an intervention for Miss Hollister? I think we should. She's probably hitting the sauce early in the morning. I bet she's got a cup of vodka, a red Solo cup. What do y'all think?
Yeah, she does.
More of a
What?
Hey, don't do that.
Red Solo cup. All right, so that will be 1.12. So I'm going to put 1.12 in here, and I should feel good about myself. Ding! That's all they ask? Oh no, this is a continue. Oh God, this probably got 15 parts. All right, now I'm going to approach 2 from the right. So I'm going to, I can't move this, so I'm going to have to delete it and draw another on the left side of 2.
Priority 1 message coming in on secured channel.
As I approach 2 from the left, from the right, what am I approaching? .31, Hubert. That's right, class. Good, Miss Holcomb. Miss Holcomb, am I still breaking up to you? 1.31. So somebody tell me, does the limit at x approaches 2, does it exist? Yes or no? As I approach from the left, it's 1.12. As I approach from the right, it's 1.31. Does the limit exist at x is equal to 2? Good job, Miss Holcomb. No, it does not. If they ask that, I don't know if they're going to ask that or not. Yes. Since there's no sign on the right side, that means, does the limit exist at x is equal to 2? No, because this does not equal this. So it does not exist. This is a good test question, but I just don't like the piecewise functions because they can confuse students. Y'all want to do this one again? Yes or no?
Yeah.
All right. All right, y'all do this one. I'll blow it up. Hold on. Let me move this out of the way. There you go. All right, we'll do this one first. I'll let y'all do this one and then I don't know if I can take it down. No, I can't. We'll have to do it together. Go ahead and write it down though and do a sketch. You don't have to write down all these words, okay? Don't just write down limit p of x as x approaches 1 from the left side. Write that down and then draw this, and then that's all you need to do. I'm going to check on the roll. Hold on just a second. I'm going to move this over here. And I'm going to do this while y'all are working on that problem. Oh, I hate Tri-County Tech. I got to go to, I'm sorry, I got to go to Mozilla Firefox so I can pull up.
Hubert, did you by chance take roll earlier?
No, I'm fixing to right now.
Okay, I was just double checking. I was going to make it easier.
Yeah, I have to go to another search engine because once Tri-County logs you out, you have to log out of the search engine and get back in
Oh, that's
because
cool.
we have cutting edge technology.
Right. I was just letting you know I was about 5 minutes late into the class.
Hold on, and I'll say I'm only checking who wasn't here Tuesday. Hold on just a second. Faculty attendance tracker. Attendance tracker. Math 130. Attendance. Okay, I can't see the enrollment. Hold on just a second. I'm gonna have to move this over. And put this back. Okay, Bagwell, I don't see Bagwell. Cobb is here. Was that you, Mr. Cobb, that said something?
No, sir, that was John
Okay.
Wood or Jason Wood.
Okay, Krieger is here. And I thought I saw Wiggins. Hold on. Yep. So the only person that I do not see here this week is Bagwell. It's the only one I don't see. Okay, so that's done. Y'all ain't got to worry about attendance now. We can just get out of here whenever time comes. All right. Sorry I have to do that, but I don't even want to go there. All right, so here we go. I'm going to cover up the right side of +1. So what is, as x approaches +1, what is my y approaching? 0.85, Hubert. That's right, class. Thank you for the interaction. I try to watch the conversation chat, but it's on my small TV and it's over to the left and I don't see it. So I'm sorry, Miss. I think Miss Holcomb is answering my questions. Thank you, Miss Holcomb, and Mr. Abdallah and Miss Holcomb. The rest of y'all suck that don't talk to me. Next, what does it say next? Continue. And it says from the right. So now I'm going to cover up the left. And what is, as I approach from the right, what am I approaching y? 101. So I type in 101. And that should equal, and they don't equal each other, so therefore the limit does not what?
Does not exist.
So even though it's a good test question as far as what they're asking, I don't like piecewise functions, so I probably will not give you a piecewise function, but I may give you another function and it asks you the same type question. Next. 1.219/10. Okay, here we go. This is a test question. So I'm just going to do this one on the whiteboard. This is our algebraic functions. These are the ones that you solve algebraically. And yes, you will see these on the test, and the graphical ones that I told you will be on there too. Limit x squared minus 4, x is approaching -2. And that's x plus 2. Sorry. Well, first of all, you need to make a note. There is an open circle. Where? Why is there an open circle at x is equal to -2? Come on, y'all can do it. Why is there an open circle at x is equal to -2 on the graph? There is an open circle on the graph at x is equal to -2. Why?
Because x can never equal -2.
Because, look, what will it give you if it does?
An undefined number.
It will give you 0 in the what?
Denominator.
Thank you. Appreciate the interaction. There is an open circle at x is equal to -2 because it will give you a 0 in the denominator, causing, oh, shoot.
An undefined
Causing
number.
an open circle on the graph. Now, why did I write that in red? Because you need to address that first. Then, after you write down that there's an open circle at x is equal to -2, then you need to do your algebra. So after you address this, then you need to do your algebra. Limit as x approaches -2 of x plus 2, x minus 2 over x plus 2. And what happens to the x plus 2s?
Cancel.
They cancel.
Therefore, you get x minus 2, which will give you plus -2 minus 2.
0.
-4 is the limit at 2. At -2. That right there is a test question, which I told you that the other day. Delete 1.252/17. Use the graph to find the following limits and function values. Okay, this one says A. What's happening to the function at 2 from the what? 2 from the left. That means I'm going to cover up the right-hand side of 2, which right now I can't see it, so I got to bring this down a little bit. I'm sorry. There. So I'm going to cover up the right-hand side of 2. And y'all can, there. Everybody with me? Okay, now somebody tell me, as I come from the left-hand side and I approach 2, what am I hitting y in terms of y?
Intercept.
Right here. What's y?
5.
5. So at 2 from the negative, that should be 5. This looks like a test question because if they ask to prove come from the right, and then is this a function? I mean, is this a limit? Does the limit exist? This is a test question. So check. Yep, that's what they're going to do. Now we're going to approach 2 from the right. No, I don't want that. So that means I'm going to cover up the left-hand side. So somebody tell me, as I approach 2 from the right-hand side, I get -5, boop, -4, boop, -3, boop, 2. What is my y? What am I approaching?
3.
3. What was the first one? 5. Does 5 equal 3? Yes or no?
Nope.
So therefore, the limit does not what?
Exist.
Does not exist. That is a test question. That's the kind of question I would put versus that piecewise function. I'd rather give you something like this. And f of 2 is undefined because it's got an open circle right there. Well, it's not undefined because you've got a closed circle right there that cancels out. So f of 2 should be 5. Now, if you had 2 closed circles, open circles, that would be undefined. But since you do have a closed circle right here at 2, that closed circle cancels out that open circle. If you had 2 open circles, it would be undefined. I like that question. That's a good question. Y'all sure are quiet today. 1.279/24. I don't know how many questions this makes, but continuous over the, yeah, it is continuous, and I'll tell you why. First of all, what does your family of graphs tell you a square root function looks like? Well, it looks like this, and you know this because you know your family of graphs. It looks like that. Everybody with me? What does the -8 mean? Does that mean a horizontal shift or vertical shift?
Horizontal.
Horizontal shift of what? Of what? Tell me. Does that mean to the left 8 or right 8?
Right.
Right. Good job. 1, 2, 3, 4, 5, 6, 7, 8. And this blue one is going to the trash heap right now. Okay, let me get another blue one. Is there any breaks in this function? Yes or no? Is there any open circles or anything like that? Yes or no?
No. No.
Nope. Miss Holcomb says no, and Mr. Melnick says no. So therefore, it is what? Continuous. Not continuous, there would be a break or open circle or something in there. So this is continuous because the function is intact. It keeps going. It starts right here, and it keeps going. There's nothing impeding on the function. So it is continuous from, let's see, I guess you'd say from 8 to infinity. So hold on. Yes, the function is continuous. That's a good test question because it just checks to see if you know your parent graphs, if you can sketch it, and do you know what the heck you're doing? It's real simple. And what that's saying is there's no breaks. Everything is like it should be for this function. That's what B says. Because there's nothing, it looks just like the black one, only it's got a horizontal shift of 8 to the right. There's nothing impeding on this. Now, what would be impeding? Something like this. If they said that the following function looks like this, 1, 2, 3, 4, 5, 6, and they did something like this, and then open circle, and then open circle, and then like that, then that would be not continuous because there's a break, and there's 2 open circles right here. If there was a closed circle here, then it would be continuous, but there would be an exception because this function is not the same as this function. So I'm just showing you, I'm showing you what would be not continuous. This would be not continuous. I'm not going to ask you anything tricky like that, especially on limits. All right, that's the homework. How we feel? Everybody feel good? Send a homework question in?
Yes, sir.
Good, good. Say again?
I said I'm doing good.
Okay, good. Good. We're all got enough to drink this morning. Miss Hollister does. She's still flying. All right, let's go to the handy dandy PowerPoint. I don't know how far we got. Does anybody know? Nobody's going to talk to me, so I don't know why I'm asking. There we go. Let's see. I think we're through. I think we got to the algebra, did we not? I think that's 1.3. Yeah, we did these. That's 1.2. 1.3. I'm just using these PowerPoints not for y'all. I'm using them for me to keep me, you know, on the. I think we got here, did we not? Somebody look in your notes. Did we get the average rate of change? Yeah. Remember me telling you that I've already gone over this with you? Remember? Changing the tangent line to a secant line? I mean, the secant line to a tangent line? Y'all remember that? Okay. Yeah, 2 or 3 of y'all are communicating through chat, and that's fine. Okay. I'm getting a bigger TV. I'm going to grab my son's TV and get him a bigger one because his TV is the same size as this TV right here, right there. This TV is like very small. So I'm going to trade with him. I'll shut up. Okay, I told y'all that the difference quotient was nothing but the what? What is that formula for right there?
That slope.
The slope. The difference quotient is nothing but the slope. All right, and that's where they're leading you right there. There it is, and then they're going to, okay, so for the y, f of x equal to x squared, we're not going to do that because I've already shown you that. So we're going to go through this, and we're going to get to the difference quotient. Rate of change is another word for slope. You need to write that down. Rate of change is another word for slope. See, here we go. Difference quotient right there. There's your x. There's your x plus h. And there is x plus h and f of x plus h. You plug it into the slope formula, you get that. All right, here is a question that could be on the test right here. Now, we've already done this, but I didn't do this right here. So I want everybody to find the difference quotient with x squared. F of x is equal to x squared. So I'm going to write it down. F of x is equal to x squared. And they want to know x is equal to 5 and x is equal to 3. So I want everybody to go ahead and get started on that. Go ahead and let's do the difference quotient. Yeah, as I was cleaning up, guess what I found? I found a whole bag of Sour Patch Kids.
Are those edibles, Hubert?
Are they what?
Edibles.
Yeah. Yeah, that's what they are.
Gosh, Hubert, you were getting on me. Look at you.
I know. Yeah. I got that. I got those, and I'm already high as a kite. Actually, I put cocaine dust in mine, and I drink bourbon because everybody knows that bourbon and Coke go together, right? Nobody's going to say anything. What kind of Coke, Hubert? No, I can't tell you that.
Hubert likes to go skiing.
Yeah, yeah. I like the snow, yes. I'll tell you all a secret. When I went down to MEPS, which is the place that you go to before you go to boot camp, they tested me twice because they didn't believe that I'd never done drugs before. I told them I'd never done drugs. And to this day, I still can tell you I've never done drugs before because I'm not a drug person. I'm a bourbon person, but I'm not a drug person. Just don't do them.
Amen, brother.
I always had a dad that was bigger than I was, and I was scared to death of him, and he would probably, I don't think he would shoot me for doing drugs, but I think he would beat the crap out of me for doing drugs. And I just ain't got no use for them, especially the potheads. Those are the ones I really can't stand. Anyway, let's go ahead and get started. We used to push them down in the dark hall at West Side. So I know I'm mean. All right, so here we go. I'm going to write this. I'm going to write f of x plus h, and I'm going to put that in brackets, minus f of x, and I'm going to put that in brackets, over h. And to make it, I got to use my highlighters. So we're going to do this in orange, and we're going to do this in yellow. So here we go. Brackets. Parentheses squared minus brackets, and that x squared goes in there, all over h. And this is my and the yellow is right here. Now, the reason I'm doing this is because people that have never seen the difference quotient, like people that were not in my 109 last semester, or people that didn't take 110 or Algebra 2 or Pre-Cal and somehow got into this class, you might need to put those brackets. Now, this says f of x plus 8. So whenever I have something in parentheses with a function, that means I've got to plug what? That into the function. So I'm going to plug that x plus h into this x, and that gives me x plus h quantity squared. And that's going to give me shortcut number 1, which is x squared plus 2xh plus h squared minus x squared over h. And the x squareds cancel. The x squareds cancel, and that leaves you with 2x after canceling, 2x plus h. Everybody with me? Now, I'm going to apply the limit theory to this because I've already showed you how to do this. So I'm going to apply the limit theory to this right here as h approaches 0. So 2x plus h, limit as h approaches 0. Therefore, what do we have? 2x. So the derivative of f of x is equal to x squared is f prime of x is equal to 2x. And they want you to plug in 5 and 3. F prime of 5 is equal to 10. So that's the slope of the line at 5. and the slope of the line at x is equal to 3 is what? 6. So that is an example of where we're going with this. So put this on there for a couple more seconds. Okay, some of you might not have got everything written down there. And you get an algebraic function of 2x plus h. This is all algebra. And then you take the limit theory, which you're learning now, and you apply that limit theory to the algebraic function, and voila, you get calculus, which is called the derivative. And the derivative is the equation for the slope of the line at any point on the function of the tangent line. So what is the slope of the tangent line at x is equal to 5? That's what that means. So I'm going to write it out beside it. The slope of the tangent line at x is equal to 5 is 10 over 1, or 10. The slope of the tangent line at x is equal to 3 is 6 over 1, or 6. Okay. And let's see where they're heading with this on the. Let's see what they get. Okay, they're just plugging in 5 for this function, I guess. I don't know what they're doing there. Okay, here you go. They're actually plugging in the numbers, and we're not doing this. We're not doing this. We're actually finding the derivative. I'm jumping ahead of them, so I'm sorry. They're plugging in the numbers, and that's okay. You can plug the numbers in. When they give you the x is equal and h is equal, just plug them in. They're not doing what I jumped the gun. I'm sorry. There we go. This is what I'm doing. Okay. And that's what I'm showing you how to do. And we're going to go past this. I'm looking for something. I think it's in 1.4. Ooh, that's a real good one. That one will make you work a little bit. I'd write that one down. F of x is equal to 3 over x. And I can show you where we're going with this. F of x is equal to 3 over x. I'll show you where we're going. You can plug in all the stuff and you'll get, those 3 dots mean, as Dr. Harden at Clemson, you know what to do. That means you know what to do. Okay, those 3 dots mean do the work. And you get all of this confuzzle. 3x minus 3, x plus h, over x plus x times x plus h, all over h. And then you try to cancel, and then you do the limit as x approaches 0 or h approaches 0, and you keep doing the work because you're going to get that h to cancel out. So in other words, what happens? Well, you're going to come out with this. I'm going to show you. This is algebra plus limit is equal to calc. All right. I'm sorry. Hold on. This is where we'll end today. What in the world's going on? There we go. All right. So this is what we're doing. This is what we're learning. This is where I'm taking you. All right. And you get something down here. Or where we're ending up with this is bypassing the algebra and the limit theory, and we're going to this. And I just did all of this stuff in one step. Okay? So I'm just telling, oops, that's a negative, yeah, -3 x to the -2. This right here, or f prime of x is equal to -3 over x squared. I just did it in one step instead of doing all of this stuff over here. So this is where we're going. We're going to leave this behind, and we're going to be doing this on the test. That's where we're going in what chapter are we in? 1.4 and 1.5 and 1.6. We're going to be doing this. So what y'all need to be working on for homework this weekend is, and I'll show you what they're going to get here. There it is. Now, what happens when you plug in h is equal to 0? Somebody tell me what you get. Right here, -3 over, what did they get? -3 over x times x plus h. -3 over x times x plus h. Limit as h approaches 0. What happens? What's x plus 0? What's x plus 0? X. And what's x times x?
X squared.
Oh my gosh, look at there. Same thing. So that's where we're heading. This is 1.4, 1.5, and 1.6, I think. 1.4 is the derivative, 1.5 is the product rule, and 1.6 is like the quotient rule, I think. That's where we're heading. So what do y'all need to be working on? Y'all need to be working on 1.1 homework through 1.3 homework. That's what y'all should be working on this weekend. Y'all have a good one. And I've already taken the roll, so y'all get out of here, and I'll see y'all, and have a good weekend.
Hey, Hubert.
Yes, sir.
I had a question for you.